Find the equation of the tangent line for y equals sine cubed x times cosine x at the point pi over 4, comma 1/4. To find the equation of the tangent line, we need the x and y coordinates of the point. Those were given. And we need the slope of the tangent line. That's found by taking the derivative. The first thing we need to do is take the derivative of this function. Y equals to sine cubed x times cosine x. We're therefore going to make use of the product rule, but before we do that, let's rewrite the sine cubed x as sine of x and then quantity cubed to remind us the order in which to take the derivative. The derivative, y prime, or dy dx, will be product rule. Derivative of the first. The first is an expression to the 3 power. We start with the power rule. Bring the power down, 3. Leave the inside alone, sine x, subtract 1 from the power, it'll now be to a 2. Multiply by the derivative of the inside to complete the chain rule. Derivative of sine is cosine. Derivative of the first times the second left alone plus the first left alone times the derivative of the second. The derivative of cosine is negative sine. We're going to want to rewrite this to look a little bit nicer for evaluating. We have 3 times sine squared of x times cosine x. We can call that cosine squared of x. And then we have a positive times a negative. Everything's multiplied there, so a negative. And we have a sine cubed times a sine, which will be sine to the 4th of x. The slope is found by evaluating the derivative at the x-coordinate. Now the x-coordinate is pi over 4. So we're going to plug in pi over 4 for all the x's. That will give us 3 times sine squared of pi over 4 times cosine squared of pi over 4 minus sine to the 4th of pi over 4. But this means to work out the trig functions first and then raise to the powers. Sine squared of pi over 4 is sine of pi over 4 and then square it. Cosine squared of pi over 4 is cosine of pi over 4 and then square it. Sine to the 4th of pi over 4 is work out the sine of pi over 4 first and then raise it to the 4th power. So we can write it that way as well. So the slope, which is y prime of pi over 4, will be 3 times sine of pi over 4 is a root 2 over 2, and we have that squared. Cosine of pi over 4 is the same thing, root 2 over 2. And then we have sine of pi over 4 again, this time raised to the 4th power. Now we'll square root 2 over 2. You can square them each. Root 2 squared is a 2. 2 squared is a 4. Likewise for the next one, also a 2 over 4. The root 2 over 2 raised to the 4th, one way to work that out is multiply it times itself 4 times, but you can also work it out by writing it into groups where the powers add up to 4. So you can do a root 2 over 2 squared times another root 2 over 2 squared. As long as the exponents add up to 4, you can break it up like that. So I'll just run it as a squared and a squared. 2 plus 2 does equal 4. That just helps to make it a little easier to work it out. It's especially useful when you have a really high power. So y here equals to 3 times 2 over 4 can reduce to 1 over 2. That'll be true for both those. Minus root 2 squared is 2 over 2 squared is 4. So we have a 2 over 4, and we have another 2 over 4. Multiplying 3 times 1/2 times 1/2, multiply all the numerators. 3 times 1 is a 3. Multiply the denominators. 2 times 2 is a 4. And then we have minus a 2 over 4 and another 2 over 4, which can reduce to a 1/2 and a 1/2. And we'll have 3 over 4 minus, multiply the numerators 1, multiply the denominators 4. These are already over a common denominator. 3 minus 1 is 2. 2 over 4 can reduce to 1/2. It looks like I have a slope of 1/2. I have the point x and y coordinates already given to me. I can now write the equation of the tangent line using the point slope formula. Y minus the y coordinate of the point, that's here, that's the 1/4. Y minus 1/4 equals the slope, which is 1/2, we just found that, times x minus the x coordinate, which is a pi over 4. That's the point slope formula. That's for the setup, but we want to put it into a slope intercept form. That's where we solve for y. So we're going to start by distributing the 1/2 in, and that will give us 1/2 x. And then 1/2 times pi over 4, multiply the numerators. 1 times pi is pi, multiply the denominators. 2 times 4 is an 8. To solve for y, we're going to add the 1/4 to the other side. And I will have then a minus pi over 8 plus a 1 over 4. Now pi over 8 is just a constant. 1 over 4 is just a constant. That's one way to leave it. It is possible that this could be put over a common denominator, perhaps, for the constant. And we will write that version as well. I'm going to put the 1 over 4 first, since it's positive, and then minus the pi over the 8. I need a common denominator between them if I'm going to write it in another form, but here's one form you might find it in, where you just have them separated like so. Sometimes I'll put parentheses around it even, since it all represents a constant. And then another version for this would be multiply that first term by 2 over 2 to get the common denominator, so that'll give it 2 over 8. And now we can combine them together. So here's an alternate way to write this. It'll be 1/2 x plus, and the overall constant will be 2 minus pi all over 8. And so there's two different ways that you could write the equation of the tangent line to the function y at the point pi over 4, 1/4. Y equals 1/2 x minus pi over 8 plus 1/4, or y equals 1/2 x plus 2 minus pi over 8. Both ways would work.